All right, gang, Math 5130. Going to go through very briefly how to present the results of a dependent matched pairs t-test. And a lot of this should be just if you're really paying attention and we're connecting at all, it should be pretty clear what we're going to do in this presentation of the results. First thing, let me pump the brakes and describe the data set to you just a little bit. We have 8. You can see down here someplace I did the length. So there are 8 subjects. And there's a blood pressure 1 followed by a blood pressure 2 measurements that are taken on the same person. So for example, the subject with ID 1 had a blood pressure of 128. And something happened. There was some lapse of time, a treatment, a medication, whatever it may be, was given, and then measured the blood pressure later. So we call that BP2, and it was 122. So we'll get into the research question in just a second. So it should be clear to you by now that the first focus is on describing our sample. So we have 8 patients. Observed means for blood pressure standard deviations in parentheses. I get that from the output. Again, we've covered this quite a bit, so I'm not going to go into dive into too much of the weeds. Same thing, mean 133, standard deviation 13.36. I ran a box plot, which you can see I executed right here, and there are no outliers, so I report that. It actually turns out that no outliers is an assumption that needs to be tested for a matched pairs t-test. And the next thing I did, final thing I did in that paragraph was be transparent and let the reader know what statistical software package I used. The rest of this should be very straightforward. I'm not going to go into much of that. And again, just copy paste that from the output. The research question would be posed like this. Is the mean of the difference for BP1 and BP2 statistically significant? Well, you can see that I ran the paired t-test right here, designated by paired equal true. So the result was significant, T, because I have a T right there. The degrees of freedom are 7. The test statistic is equal to 3. And my p-value was significant at the 0.05 level, indicating that the mean difference of BP1 and BP2 is the mean of the differences are different than 0. Next thing I do is I calculate the mean of the differences, which is given right here, 4.5. And then I have to calculate the standard deviation of the differences. So I have to create those. So I created a new variable called diff, differences, BP2 minus BP1. I took the standard deviation of this and got 4.24. The 95% confidence interval is given in the output, right? So I report that, and then I created a table down here with the mean standard deviation for BP1 and BP2 and the differences and t-value and p-value. One of the assumptions for a dependent samples t-test is that our dependent variable is normally distributed. So you can see at the bottom what I did is I ran a Shapiro-Wilk normality test for BP1, BP2. Neither one was statistically significant. Remember, the null hypothesis is what? That the distribution, the sample data appear to come from a distribution that is normally distributed. We do not reject that statement because our p-values are greater than 0.05. So we can assume this sample data came from a distribution that is normally distributed. That's about all there is to it. I can't make this part hard if I tried, and I wouldn't try to make anything hard anyway because you're just learning, I know learning statistics for many people can be very frustrating, so I try to keep it as straightforward as possible. Seems like I'm forgetting something, but I can't imagine what it is. I'm not going to present this in StackCrunch because fighting, I've already demonstrated how to run this thing in a previous video. There's just nothing really new. I've demonstrated how to run Shapiro-Wilk in a previous video, so I think you can review your notes from the previous video, which is a requirement for the class to watch those, and figure that out very, very, very easily. If not, just reach out. All right, take care.